So we're continuing with chapter 6. Okay, the last section we did was 6.3. We're not doing 6.4. In 6.5, we are continuing with operations of radical expressions, and we're going to be rationalizing the denominator and using some of these rules that we saw in 6.3. So we're going to be using a product property and a quotient property. If you have two values multiplied together, you can always separate them. Okay, and this goes forwards and backwards. If it starts off as 2, you can multiply them together. That's why we have the double-sided arrow. Okay, because it doesn't matter which way you're going. Okay, and if the index value is even, sorry, I forgot to switch that for you guys. Okay, if n is even, then whatever's underneath does have to be positive, so we aren't dealing with those values of I. And then the quotient property, we're going to talk about a few different ways that we can use that. Okay, so one way is you can split this up into the nth root of the numerator over the nth root of the denominator. And when you look these up in your textbook, you'll see these little stipulations, like it'll say where b cannot be 0. And that's just because if you divide it by 0, you would not get an answer, and so you will see these restrictions there. All right, so in the example part, I want you guys to try these first two based on those properties. So root 12 times root 3, I want you to see if you can simplify that. And then the cube root of 24, let's see if you can simplify those. If you haven't given this a try yet, make sure you give it a try. I'm just going to be calling on you guys in a moment to help me with what you're thinking. Okay, so Caleb, tell me what you did for number 1 here.
I added the things together.
You didn't add them, did you? Oh, okay. But really, what do you want to do?
Multiply.
Yep. So if you multiply them, what do you get? You got it. 12 times 3, 36. Yep. And the square root of 36 is? Yep. Okay, so that's what you're going to simplify to. All right. And then for number 2, Cody, tell me what you were thinking for that. What? Okay, so did we use this product property here? So just split it up into 2 products? Okay, so what 2 values can you multiply to get 24? That would be helpful for this. Yeah, okay, so we're going to change it into the cube root of 8 times the cube root of 3. All right, and then Cody, why did you choose like 8 and 3 instead of 6 and 4? Okay, yeah, so when you take the cube root of 8, right, that's a perfect cube. What's the cube root of 8? 2. Yep, so it's going to be 2, and then it's the cube root of 3. All right, nice work. All right, now for the next example. Okay, I want you guys to use this quotient property.
Never mind.
Don't say that, but just take a second to process. Okay, so I want you to start by using the quotient property. Okay, so the first thing we should do is we should split it up, and then I want you to think about how those are going to simplify. Okay? Okay, so Arnav, you want to tell me how you got this one? Good. Okay, so the square root of 25 is 5. When you take the square root here, remember you ask yourself how many times does 2 go into 4? If it's twice, you get x squared. Okay, now sometimes you might see a fraction underneath the radical, and instead of splitting it up first, we're going to simplify first. Okay, so we're actually going to simplify this, and then we are going to use the product. Okay, and that's because I want you guys to start noticing, like, oh, this might be something that we can simplify. So this is the cube root of 54, and then this is x to the 4th divided by 2x. Okay, so instead of splitting this up, if you have 54 divided by 2, what does that simplify to? Yep. Can you guys tell me what x to the 4th divided by x is? X to the 3rd. Great. Okay, so this is going to be a lot simpler than trying to rationalize. So if you can simplify, I do want you to do that first. And 27 is a perfect cube, right? Okay, so Silas, what would we get for our final answer here, just whenever you get it?
3x.
Yes. Cube root of 27, 3. Cube root of x cubed, x. There we go. All right, so a lot of times in this section, it's going to tell you to simplify. So there's a few things you want to look for to make sure that you are in the simplest form. Okay, so the first thing is that the index value, n, is as small as possible. Okay, so the nth root. Okay, the next thing is that the radicand contains no factors other than 1 that are nth powers of an integer or polynomial. And I know that's a lot to process. So when they're saying they are nth powers, that just means if they're perfect squares or cubes or 4th roots, etc. Right? 5th root, 6th root. So when they say that they're nth powers, they mean that it's a perfect square. 2 squared, 3 squared. Okay, perfect cubes. 2 cubed, 3 cubed. Okay, and then the radicand is going to contain no fractions. And we've used that term radicand several times. We do have to know what that means. Remember, the radicand is just the value under the radical. Well, anytime it says the radicand, that's just whatever is underneath your radical, okay, for whatever root you have, the nth root. Remember, we also cannot have radicals appear in the denominator. If they do, then we use what process? Yep, we're going to rationalize. Great. Okay, so if you need to, we will rationalize. Okay, when you are simplifying each expression, we are going to assume that your variables are positive. Okay. And the reason why I'm telling you that is because your book doesn't necessarily do that, and you'll see if you ever were to look things like solutions up in the back, you would see that there'd be absolute value symbols. Okay, this is our first time learning this, so we're not going to worry about that. We're just going to worry about our simplification here. All right, now, really, you guys can do the first row without me. Okay, A, B, and C. So I'm going to give you a couple minutes right now to do that. And then once you finish A, B, and C, if you want to check in with your row or your partner, or I'll wander around if you want to ask me questions. I see some really nice factor trees. All right, so it looks like the first two went really well. Okay, like I said, you guys did a nice job with your factor trees. Your 2 and 30, 2 and 15, 3 and 5. Okay, so if it's a square root, then you're looking for 2. Okay, so then the 2 is going to come out. Okay, and then whatever is left inside, what do I do with the 3 and 5? Multiply them together. Great. Okay, so the 15 is going to be here. So 2 goes into 3 one time, 1 left over. 2 goes into 22 11 times with nothing left over. Okay, so 2ab to the 11th, square root of 15a is your final answer. Make sure that your radical encompasses everything that's underneath, okay? For this, if you did your factor tree, it's 2 and 2. So because you have 4 here, there's nothing that you can take out. And so what I usually do is I make my 4th root, and I put the 4 there, and then 4 goes into 5 one time, 1's left over. 4 goes into 25 times. So xy to the 5th, 4th root of 4x. We don't need all that, but we got it. All right, any questions for me in A or B? Okay, I know the negative is throwing some of us off here. So this is an odd root. Okay, so anytime you have an odd root, okay, with a negative, it's okay. So when you do this, you're going to bring the negative out. Okay, so I'm going to do the factor tree like normal. 2 and 27, 27 is 3 and 9, 9 is 3 and 3. I'm looking for a group of 3, okay, and then you are just going to bring out the negative here. So if there's a negative inside, you bring it out. Okay, and then for the what's inside now is just going to be the 2. So when you're doing this, it's like you're multiplying 2 times negative 27, a negative 3 times a negative 3 times a negative 3. When you take the cube root, it comes out. Okay, and it's okay if you don't write down the negative with that. If you just do your factor tree and keep it on the outside. Okay, and then you should have x squared. You should have y to the third. And then there are 2 y's left inside. So negative 3x squared y cubed. Okay, and if again things are too scrunched or you need to rewrite it again in the next step, that's okay. Questions for me on that? All right, and then if you started 4, that is fine. I just wanted to remind you that sometimes it is better to reduce first. So 80 and 256. Okay, some of you might know the 4th root of 256 is a perfect 4th root. Okay, I'm going to say many of us do not know that right away, and so it's going to be a lot easier to just reduce. What's a number that goes into both of those? Okay, yeah, so you can divide them both by 8. If you want something a little bit easier because it is a no calculator section, if you just want to keep reducing them by a half, you can, right? Because it's really easy to cut things in half in our head. Half of 80, 40. Half of 256, you can just do half of 250, which is 125. Half of 6 is 3. Put them together. And then you can just keep reducing. Half of 120 is 60, so it's 64. Okay, and then, like we said earlier, you can use a different number. So if you wanted to divide by 4, you can. If you're like, no, I like the evens because my brain can do those quickly, go ahead and do that. So this is what it would reduce to, no matter what you divided by the common one. And then you would have 5y to the 14th over 16z to the 4th. Okay, now you can split that up. Okay, and I want you to try to simplify the numerator and the denominator. Okay, so I'm going to give you a moment now to do that if you haven't already. If you have already simplified it, please look at your final answer. Make sure that there's nothing that you can reduce. Alright, so when you are simplifying in the numerator, okay, 5 is just going to stay there. So you have the 4th root of 5, and then 4 goes into 14. How many times? 3 times. How many left over? Sorry, I forgot about that. And then just, you'll have your notes video up, which is what we're at. I was really confused. Okay, and then once you have this, you're going to simplify here. You have 4 and 4, 2 and 2. All right, and then from there, this is going to be your final answer. You just want to leave it as 3 times 24 and use that in your factor tree, you could do that too. And then a times a is a squared, b times b cubed is b to the 4th. And then this is a problem just like we've done before. Okay, so why don't you go ahead and just simplify what's underneath the radical, and then we'll check it together, okay? Yes, whatever you get on the outside, yes, you will. And when you start to do your factor tree, if you do 2 times 36, you're going to recognize that 36 is a perfect square, right? So what I would do is I would just do 6, and then this is times the square root of 2. And then if you want to do it all at one time, you can do that as well, okay? So here you have 24 times 6 on the outside. I'm just going to write that as multiplication for right now. And then 2 is left on the inside. And then we're going to go to the variables. Okay, so this is root 2 times root 36. So root 36 becomes 6. The 2 is going to stay inside. Because the 24 is already on the outside, we're going to end up multiplying these together in just a moment. Then the same rules apply here. If the index is 2, 2 goes into itself one time, none left over. 2 goes into 4 twice, none left over. Okay, so your final answer, we're going to multiply these together. You can either set up this old school, or you can do 20 times 6 and then 4 times 6. Whichever you like better is fine. So you have 144 AB squared root 2. All right, so using that, will you guys do part B? Okay, so questions from the audience about this? Okay, yeah.
Just like any number under that, you one and that number to infinity, and then take out one constant over.
Yes, that's why I never will include the 1. Yeah, because the 1 times that will just be that same thing. Yes.
Yeah, I just think that was kind of
All right, so first step, how are we feeling? Good? Multiplying them together. And then once you get there, it's exactly like what we were doing in 6-3. If you don't have 2 of them, you can't break it down anymore. So the 14 has to stay inside. If the index is 2, 2 goes into 3 one time, 1 left over, 1 time, 1 left over. This is your final answer. Okay, thumbs up if you got that one correct. Okay, good. All right, now the next thing we're going to do, again, this is something that we did in 6-3. If the denominator is a square root okay, then what you want to do is you want to multiply the numerator and the denominator by that same value. So if it's a square root, you multiply by the square root of b, for example. So there's going to be a special pattern for that too. So if it's a square root though, this is going to be your rule. So if the denominator is a square root, you just multiply by the same thing. Okay, so we guys write that down and then simplify. Okay, and then Hayden, what did you multiply this by, top to bottom? Yeah, square root of 7x. Good. On the top and the bottom. So we're going to multiply by root 7x over root 7x. And the reason why is because this is going to give you the square root of 7x squared. When that happens, they undo the operation, and you're left with 7x on the bottom, 4 root 7x on the top. You cannot cancel these out. One is imprisoned under the radical. That's how I think of it, right? It can't get out, okay? The only thing you can simplify with are other things under the radical. So this is your final. Okay, and then Silas mentioned, well, sometimes it's not a square root, right? Sometimes we have a cube root or a fourth root. So that's going to be a different pattern. If you have the nth root of b to the x power, okay, there is a formula that we can derive. We're going to do the example first, and then we're going to talk about what that is. Okay, so for this, we have 3 divided by the 5th root of 2. Okay, and I just want you to write down what you're going to multiply that by. Okay, so write down what you're going to multiply that by, and then see if you can simplify that. Okay, so it's 3 over the 5th root of 2. All right, and then Kanan, what are you thinking? What should we multiply by here? The 5th root of what?
16.
First I thought you said 6, 7. Right? Okay, yeah, so we're going to multiply by 2 to the 4th power. Okay, and 2 to the 4th power is 16. Again, the reason why we do that is because we have the 5th root now of 2 to the 5th. 2 times 2 to the 4th is 2 to the 5th. The 5 and the 5 cancel, they're inverses. So you're left with 2 in the denominator. Okay, and then we just write the numerator as 3 times the 5th root of 16. Okay, so the formula that you can use to help you with this is the nth root of the square root, well, the nth root of b, and then this was 2 to the 4th because we needed 5. Do you guys know what the exponent is on this? 1. Okay, so if this is 4, can you guys see how this is just 5 minus 1? Okay, so the 5 we call the n value. This we would call the x value. So you just do to the power of n minus x. Okay, so in that case, 5 minus 1, we know we're going to multiply to the 4th. Okay, and if you have 2 different exponents, like with a variable, you're going to use that as well. All right, now when you are doing these, you really have 2 different methods that you can use to simplify these. A lot of times you're going to want to simplify first. Okay, for part A, we're going to do both methods together so you can see the difference, and then I'm going to let you choose which ones you would like to use. Okay, so there's nothing to simplify under the radical. So we break this up into the numerator and the denominator. Okay, once you do that, the first method is to simplify first, and I do think most of you are going to use that. Okay, which means we're going to simplify the numerator and the denominator. So we can't simplify the square root of 5, so that's going to stay underneath. But 2 goes into 5 how many times? 2, with how many left over? 1. Okay, go ahead and simplify the denominator. All right, and then 2 goes into 13 how many times? Yep, so it's b to the 6. And then the square root of b because there's 1 left over. Okay, so if you simplify first, this is the square root. So we said if the denominator is the square root of b, we're going to multiply by the square root of b over itself. If you do that, the square root of b times the square root of b is b. So b times b to the 6 is b to the 7th. Okay, so don't forget to multiply b by b to the 6. And then this would be a squared square root of 5ab. Okay, so like I said, I do think most of you are going to like that. And then some of you might just want to simplify at the end. So in method 2, you're going to rationalize first. If you rationalize first, I wouldn't necessarily multiply by the square root of b to the 13 and b to the 13. You can. You will have to simplify at the end, but you can do that. Instead, you want to go to the next value that's going to make that an even number. So if you choose to rationalize first, you would start by multiplying by root b over b. Okay, which would be b to the 14th on the bottom. 2 goes into 14 7 times, so it's b to the 7th. And then you would just have to simplify the numerator. Again, 5 is going to stay underneath. 2 goes in there 2 times, 1 left over, and then there's not enough to take any of the b's out. So you get the same thing, all right? So I'm going to let you decide for B and C what method you want to use. Again, I think a lot of you are going to like method 1, and then that out. Okay, so if you chose to simplify first, 20 is the square root of 4 times the square root of 5. That might be something that you just pick out the perfect square. You don't necessarily have to factor tree it. So you get 2 square root of 5x over, and then the 3 is going to stay inside. 2 goes into 5 twice with 1 left over. And then when we get it down to here, now all we have to do, because it's a square root, if it's a square root, you multiply by the exact same square root, okay, over itself. So when you multiply root 3y times root 3y, you get 3y. Don't forget you're multiplying all of those together. And then see if you can do the numerator as well. If you finish those actions, you can feel free to grab the homework and look up your assignment. But also check your final answer to make sure you did it right. Okay, so 3y cubed is the denominator. And then on the top, you only have 2 on the outside. So root 5x times root 3y is going to be the square root of 15xy. Okay, so 2 square root 15xy over 3y cubed. Okay, so when you're starting these, the first step, once you check to make sure there's nothing that can simplify, is to separate. Okay, once you've separated them, you can simplify if possible. Here you can't take anything out. Here you can't take anything out. So then we want to rationalize. In order for something to come out, you need to have 4 of them. Okay, so it has to be the 4th root. You only have 1 5. So remember, it's like 5 to the 1st. 4 minus 1 is 3, so it's 5 to the 3rd. 4 minus 2 is 2. Do you guys remember doing this in 6-3? I know that was in December now, so it's been a little bit. Okay, so it's okay if they have different, exponents. Okay, so what happens here is you get the 4th root of 5 to the 4th, b to the 4th. Okay, that's why you're able to simplify the denominator into 5b. If you don't have them to the 4th power, you can't simplify that. Okay, and then on the top, 5 cubed is 125. And then put these in alphabetical order if you can. If you didn't, don't worry about it. It's not something I'll take off points for. So you should have 125b squared x cubed over 5b. Okay, and then your homework is mandatory. Okay, so it's mandatory due tomorrow. I'm going to give you time right now to work on that.